Let's use the raise strategy to solve this problem. So first for raise, we're going to read the problem carefully, and then we're going to read it again. Let's do that. Spinner X is divided into 4 equal sections, and spinner Y is divided into 3 equal sections. The possible outcomes for each spinner are shown in the tree diagrams. Both spinners are spun at the same time. What's the probability that spinner X will land on 2 and spinner Y will land on blue? All right, so I'm going to read it again. Just kind of, this time I'm going to read it in my head. And what I'm doing is maybe looking for some key vocabulary words that are important here. Let's see, outcomes. Okay, what is the probability? Okay, I think maybe outcomes. So I'm talking about my outcomes of my spinners down here, and then I'm looking for the probability that spinner X will land on 2 and spinner Y will land on blue. All right, let's think about what the question is asking. And we kind of just answered that, didn't we? So let me underline that question. What is the probability that spinner X will land on 2 and spinner Y will land on blue? You know what? I'm actually going to mark that on my diagram here. So for spinner X, I'm going to circle the number 2. And for spinner Y, I'm going to circle blue, because that's what I'm looking for, the probability that those two things will happen. Okay, let's see. So for information, we need to look for our important information. And I think we've actually kind of done that. We've emphasized that spinner X needs to land on 2 and spinner Y needs to land on blue. We also need to cross out any distracting information. In this problem, I really don't see any distracting information. All of this is basically necessary. We need to know that there are 4 outcomes that are possible for spinner X and 3 outcomes that are possible for spinner Y. So now we're going to strategize. So we're going to choose a strategy to use to help us here. And we don't have to choose just one. I'm going to choose to draw a picture or a diagram. So I'm actually going to draw spinner X and I'm going to draw spinner Y. There we go. So there's my picture, and I'm going to put a star next to the ones that I care about. All right. And actually, I think this visual is, for me, this is actually a little bit easier to think about, because what I'm trying to think about is the probability of getting a 2 and a blue, right? So with my picture here, I can easily see that's 1 out of 4. So I have a 1 out of 4 probability of getting a 2. And for my spinner Y, I can see I have a 1 out of 3 probability of getting blue, because there's 3 colors and one of those is blue. So the probability of 2 is 4. The probability of blue is 1/3. So now the question is, how are these two probabilities related? So does the spin on one spinner affect another, or does it not? Are they dependent or independent? Those two words are not actually in the problem. They're not written there, but they are important to consider. And in this case, these are independent events. What I do to one spinner is not going to affect the other spinner. So that means to calculate the probability of these two things happening, I can multiply the two probabilities together. So I figured out what I need to do. I need to multiply 1/4 times 1/3. So let's do that. So I'm going to multiply my numerators and multiply my denominators, and that gives me 1/12. There we go, and that's answer choice B. So this is one strategy you could use to solve this problem. Let me show you another one, and this other strategy might actually help us check our work here. So I've made some space over here for spinner X. It could be a 1, 2, a 3, or a 4, right? And then if I spin a 1 on spinner X, I could get red, green, or blue. If I spin a 2 on spinner X, on spinner Y, I could again get red, green, or blue. And the same thing for if I got a 3 or a 4, right? So there's 12 different outcomes here. I could get a 1 in red, a 1 in green, a 1 in blue, a 2 in red, a 2 in green, a 2 in blue, and so on. But I can see my 12 different outcomes here. And so let me highlight the one that corresponds to what I am concerned about. I am looking for the one that is 2 and blue. So this one right here, I'm trying to find the probability of getting that specific outcome, of getting a 2 and then getting a blue, right? So there's 12 outcomes, and that's the one that I care about. So that's another way to see that the answer here would be 1 out of 12. So I found a way to check my work to be sure that it's reasonable. And this is one way you can use the raise strategy to be sure that you are solving problems confidently and correctly.